Hi, we've been working on parallelograms. So far we've had just any old parallelogram. We've talked about rhombus. Now we're going to talk about rectangles and squares. So rectangle. What makes a rectangle different than any other parallelogram is it has 4 right angles. So all those properties that we talked about with the parallelogram still apply, but it's a little bit more specific. So all of these are 90s. That's what makes a rectangle a rectangle. It's a parallelogram with 4 right angles. So no matter what, this is 90. So if I put a 2x here, I can say 2x equals 90. If I put a 10y here, I can say 10y equals 90. So I might put things in the corner, and you got to set each corner equal to 90. Each corner equal to 90. The other thing that's different about a parallelogram or a rhombus is that the diagonals are congruent. So when you're talking about the diagonals, this diagonal is going to match this diagonal. And because the center is still the center, I still know these diagonals bisect each other because it's a parallelogram. I know whatever this is, all 3 of them are going to be the same. So if this is 5, every single segment here is 5. If I say the whole segment here is 24, I can cut that in half and say 12. I know every single segment is 12. So that's true on a rectangle. Diagonals are congruent. The other thing with a rectangle is that diagonals create an isosceles triangle. So this triangle here, I've got 2 equal sides, which means I have 2 equal angles. So this angle is going to match this angle. This angle is going to match this angle. So if I say this is 30, every single one of these angles are going to be 30. Then going the other way, these are also going to match. So if I say this is 50, this is 50, this is 50, this is 50, this is 50. Now make sure you realize that these middle angles you're going to have to find. They're not 90s. On a rhombus, they were 90s, but on a rectangle, they're not. So you're going to have to find these based on the triangles. So it has a definite different configuration than the rhombus did. The rhombus, these matched. A rectangle, these matched. So let's go ahead and take a look at some examples. So in these examples, the number that I'm going to give you, I'm going to put in blue. So I've got to give you one of the numbers. Then I can find everything else. So this is 32. This is 32. This is 32. This is 32. So all 4 of those angles are going to be 32. Now again, be careful. It's not the same as a rhombus. A rhombus, both of these are 32, but not with a rectangle. To find the other angle of a rectangle, I got to subtract from 90 because I know the corner is going to be 90. So 90 subtract 32, I get 58. So 58 for the rest of these going around the outside. Well, now at this point, I've just got to finish my triangle. So each triangle, as always, has to add up to 180 degrees. So 180 subtract 58 and 58 is 116. I get 64. So this is 64, this is 64, which means this has to go back to 116. So that's what the angles of a rectangle look like. Again, it's not the same as a rhombus. Don't get confused with a rhombus. On a rhombus, these and these match. The middles are all 90. On a rectangle, the angles coming off the sides match. So these 4 match, these 4 match. The middles you're going to have to find. Now, the next 2 examples, I'm going to give you a middle. So if I give you a middle of, say, 68 here. Let me put that in blue. So I'm going to give you an angle. Now I'm going to find the rest of them. Well, again, I can find all my center. If this is 68, this is 68. It has to add up to 180 because it's a linear pair. So 180 subtract 68, 112. So this is 112, this is 112. So that's all my middle. Now, do your triangle. If this is 112, the 2 of these together have to add up 68. So if I take 68 and split it, I get 34 34. So these four angles are all 34s. 68 subtracted from 180 is going to give me 112 back. So that 112 has to get split. 56, 56, 56, 56. So those are all the angles of a rectangle. I'm going to do one more just like that because I think this is a little bit trickier than this one. Again, I'm going to give you something in the center. I'm going to give you 170. So this 170, I can find the rest of the center. Vertical angles are congruent. Linear pairs add up to 180. Then if this is 170, I've got 10 left over, split it. So 5, 5. This would be the same. 5, 5. If this is 10, split that. I've got 170 left. So 85, 85, 85, 85. And if you notice, these corners still add up to 90. That's kind of the key, is they've got to add up to 90 in these corners. So that's the angles of a rectangle. So when you're looking at your homework, you've got a couple of problems like this. You've got a couple of problems like this. So make sure to be really careful when you're filling out the angles. It's too easy to get these mixed up with rhombus. So just make sure you're doing it as a rectangle. The next four, let me go ahead and scroll down, or the next three, we're looking at sides. We're looking at segments. So on this next one, I'm just going to give you a bunch of numbers. 6, 5, 8. I'm going to go W, V, Z, X, Y. Well, remember, a rectangle is still a parallelogram. And with a parallelogram, we know opposite sides are congruent. So if this is 6, this is 6. If this is 8, this is 8. Same as any parallelogram. That's true for any parallelogram. With a rectangle, we know these diagonals are going to be congruent. So this is 5. Every single one of these segments will also be 5. Every single one. So all of these are going to be 5s. So on your homework, you've got a couple like this. The next one's almost the same thing. I'm going to give you one of the diagonals. AC equals 16. So if AC equals 16, corner to corner, I know corner to middle is going to be 8. So I know every single one of these is going to be 8. And then I can also say the other diagonal, D to B, is 16. So on your homework, you've got a couple like this, where I give you diagonal, and then I say like AO equals something, DO equals something, DB equals something. So you're going to fill out all the segments of the diagonals. The last one is more of an equation. So I'm going to say this is 18. 2x, 3z minus 3, 4y plus 2. Well, again, every single segment matches every single segment inside. Whatever this is the same thing. So I can set every single expression equal to 18 and then just solve for the variable. So x equals 9 because 2x equals 18. 3z minus 3 equals 18. Add the 3. I get 21. Z equals 7. 4y plus 2 also equals 18. Subtract the 2. 4y equals 16. Y equals 4. So every single one of these is going to equal the same thing. Every single one. Now the other one I'm going to be talking about today is squares. So let me go ahead and scroll to squares. When you're looking at a square is a type of a parallelogram. It's a type of a rhombus. It's a type of a rectangle. So a square actually has all the properties we've talked about, which would make you think that squares are harder than the other ones, but they're actually easier because they're so specific. There's not a lot you can do with a square. We know a square has 90-degree corners. We also know, because it's a type of a rhombus, that this diagonal is going to split that 90 into equal pieces. So the angles of a square will always look like this. I don't even have to give you anything. You're just going to fill out all of the angles. So on the homework, I think you've got a couple that look like this. You just fill them out. The center is always going to be the same also because it's a type of a rhombus. We know with a rhombus, all four equal sides. So therefore, all of these are going to have to be 90s. The same as the rhombus was. So no matter what square I give you, no matter what size of square I give you, it's always going to look like this. The segments of a square, let's take a look at this guy. So I can give you, let's say this is 14, 2x, 5y minus 1, 7z, now let's just make it 7z. Well, on a square, every single side is the same. So I can set 2x equal to 14, x equals 7. I can set 5y minus 1 equal to 14. So 5y equals 15, y equals 3. I can set 7z equal to 14, z equals 2. So every single side will be the same. Every single side. Let's take a look at another one. This one I was just trying to show the same thing. I made it a bigger square, but no matter what size square I give you, the angles aren't going to change. That never changes. So I can still just go around the outside, putting all these 45s all the way around. The middles will always be 90s. The middles will always be 90s. Now this one I'm going to make a little bit harder. Let's say I've got 3x plus 8 here, 4x plus 2 here. Let's make this a y, and let's make this one 5z. I didn't give you any numbers, but I did give you two sides that have an x. So I can set these two sides equal. 4x plus 2 equals 3x plus 8. I can set those the same. Subtract, subtract, x equals 6. Now, don't forget, you've got to plug that 6 back in. So the 6 is going to go back into the side. Doesn't matter which one you plug it into because they better give you the same number. So 4 times 6 is 24. 24 plus 2 is 26. So I get a 26 there. If I plug 6 into here, 3 times 6 is 18. 18 plus 8 is still 26. Well, if these two sides are 26, this side is 26. So I can just say y equals 26. I'm going to add a plus 1 here. I can say this side equals 26. Subtract the 1. 5z equals 25. Z equals 5. So that was a little bit harder, a little bit trickier. So because every single side was the same, I picked the two that had the same variable, set them equal, then I could plug it back in, and then say this is 26, this is 26. Two more examples. I really didn't need to put a third one of these. But again, all of these are 45s. Yeah, it gets a little redundant. But you should definitely get it right. 90s going around. 90s going around. So now, let's say I've got DB equals 5x plus 4. Let's say AC equals, let's make it AO, equals 12. Well, notice DB is corner to corner. AO is corner to middle. So this is 12, this is 12, this is 12, this is 12. But I'm trying to solve for x. So I can say 5x plus 4 equals, don't put 12, because DB is corner to corner. So 12 plus 12 is 24. So 5x equals 20, x equals 4. So you just have to make sure not to set it equal to 12, because 12 is corner to middle, DB is corner to corner. So there's two different homework assignments. There's a homework assignment involving angles, rectangles and squares. There's a homework assignment involving segments, rectangles and squares. So make sure you have both homework assignments done by Wednesday midnight, because I'm going to be posting that answer key Thursday bright and early, because I want to make sure you have all the answer keys before the graded homework assignment. The graded homework assignment, try to have turned in Friday by 1, because if you do it by Friday by 1, you get extra credit. Otherwise, it's due Sunday by midnight. So, rectangles and squares, don't get them confused with rhombuses. They're different. Have a wonderful day. This one did not have a quizzes that went with it, so I did intermix different information. I just wanted to make sure you had a video. Talk to you later. Bye-bye.